Hello, so today I will be going over another example in which we will use Routh-Hurwitz. So in this example, we're asked to write down the closed loop characteristic polynomial and find the range of the gain alpha for which the system is unstable. So just a quick refresher, remember that Routh-Hurwitz criteria must be met in order to determine the stability of the system. In this case, we are told that the system is stable, so we know that the Routh-Hurwitz criterion is met. But just to review, let's go over the first one. And we remember that there are no missing terms or no coefficients are equal to 0. Okay? Second criteria was all coefficients must have the same sign. So no sign change, right? In the first column. And we'll see how this plays into this example. But remember that this criteria is met already, so we don't need to worry about that. So I'm just going to box that on the side. That's a little note for you. And remember, for stability, we're going to be looking at Q of S, which is going to be this denominator right here. And let's go ahead and write that down. So looking at this, we're just going to take the coefficients of all of these. So we have 1, 3, 3, and alpha. Okay? And the way that you kind of like set up the Routh-Hurwitz, it kind of goes like in a little snake. So kind of like this way. Like that. I don't know if that's helpful, but I mean, take it as you wish. And here we're going to have the criteria. So that's going to be S cubed. That you always take the first here, like the first power of that, which in this case is S cubed, right? Okay. S squared, S1, and then S0, which is basically your number. And then here we're gonna put all of these numbers, and they're gonna go like in a that way. So 1, 3, 3, alpha. Then we're gonna close this off right here. And here we're gonna have B2 and C2, which we will solve for in order to determine the range of the gain alpha. So let's go ahead and do that. So first thing that we're going to find is B2. So B2 is going to be equal to, let's take the inverse of this. So it's always going to be negative 1 over whatever this number right here is. So in this case, it's 3. So we're going to put 3 right there. And then write down the matrices, which is going to be the matrices, which is going to be 1, 3, 3, and alpha. And you're going to go from here. So 1 times alpha, which is alpha, minus 3 times 3 is going to be 9. And remember, you still have that 1/3 in the front. So that would mean that you're going to distribute this. You have negative alpha over 3 plus, let's see, 1/3 times 9. That's going to be just 3. And remember, you have positive now. So that is equal to your B2. Go ahead and underline that so you have that for later. Now we're going to find C2. So I'm going to go over this, but there's another trick which I will show you after I go over this example. But you're going to have 1 over, in this case, whatever was your B2 now, right? So you're kind of like ignoring, let's say, the first column and just looking at the second and third column. So that would mean you have negative 1 over B2. And then you're going to have 3, alpha, whatever your B2 was, and 0. So a key to this is where the trick comes in. Basically, whatever you have like here, if you have a 0 here, automatically whatever is on top of that 0, that's going to be your that's going to be your answer, right? So that would be just alpha. That's what's equal to your C2. Or another trick, without even honestly having to do the matrix, is just looking at your characteristic polynomial. If you just have like, let's write it one more time. So if you just look at the last term of your characteristic polynomial, that's always going to equal to whatever you have here, the very, very last one. So that's how you also can get it. C2 equals to alpha. So now let's go ahead and use this criteria to find the gain, right? So let's let this be greater than 0. So taking whatever we had in the first one, so b2 greater than 0, we have negative alpha over 3 plus 3 equals to 0. Oh, greater than 0, sorry. Okay, move that 1 to the left. We have negative, negative. That means that our sign is going to change. So we have that. And then 3 times 3, that's going to be 9, positive 9. So here we have that. Second criteria. So C2 greater than 0. And that's just it. So now we're going to make sure that we find our gain. And that's just going to be, oh, my bad. So this was actually one more thing here that I forgot to say. So C2 was greater than 0, but remember that was just alpha. There you go. So now you're going to have alpha is going to be in between 0 and 9, and that is your gain alpha for which the system is going to be stable using this Routh-Hurwitz criterion. I hope it was helpful, and thank you for watching the video. Let me know what I can do better, or if you have any questions and comments. Thank you.